This lecture is on solving equations. If you recall, there are 4 steps involved in solving equations. Step 1. You should always remove parentheses or any grouping symbols. So things like parentheses, brackets, any grouping symbol. Okay, so that's step number 1. Step 2. You should combine like terms that are on the same side of the equal sign. So combine the like terms that's on the left side as well as the like terms that's on the right. Step 3. You must always apply the addition property first. But remember, adding both sides means you could add a positive number, you could add a negative. So you can add or subtract both sides, and that's addition property. And step 4 is where you apply the multiplication property. Okay, let's look at an example to recap what we need to do. So take for example, you're asked to solve 2x minus 5, 4 minus x equals 7 plus 5x. Notice that right in front of the parentheses there's a 5, but right in front of the 5 there is a minus. So bear in mind that the minus really belongs to the 5, and you should be distributing an entire negative 5 into the parentheses. So your next line would read 2x minus 5 with 4 makes it minus 20. Minus 5 multiplied to minus x makes it positive 5x equals 7 plus 5x. So you should always combine like terms on the same side, and that makes the left side 7x minus 20, and on the right side is 7 plus 5x. So the next thing we're going to do is to apply addition property, which pretty much brings the like terms to the same side. So since the x is on both sides, we're going to bring the x's to the left and the numbers to the right. So 7x is on the left, and so that stays, but the positive 5x is being brought over, and the minute you cross the equal sign, it changes to minus 5x. 7 stays, and minus 20 when you cross the equal sign becomes plus 20. So on the left, you now have 2x, and on the right, you now have 27. And what attaches the 2 to the x is multiplication. So to detach that, you have to divide both sides, which gives you x equals 27 over 2, and that's your answer. Now there are times when the equation carries a fraction or decimal. When that happens, you should consider step 0, which is the step prior to all the 4 steps mentioned above. And what step 0 says is to clear the fractions or decimals by multiplying each term on both sides of the equal sign by the LCD. Consider the example. Solve 1.2x minus 2.3 equal 9.7. Notice that there's decimals everywhere, and one quick way of removing the decimal is to multiply each term by the LCD. Now if you notice, each of these decimals is 1 decimal place, which means that their denominators are really 10. So you're going to multiply each term by 10. So let me remind you what is considered to be a term. Terms are separated by plus, minus, equal, okay, but definitely not multiplication and not division. So if you look at 1.2x, that's one term. 2.3, that's one term. 9.7, that's one term. So if that's three terms, that's where I multiply everyone by 10. So 1.2 times 10 makes it 12x. 2.3 times 10 is 23. And 9.7 times 10 makes it 97. So there's nothing to combine like terms. Okay, so to bring them to the same side, I have to apply addition property. And minus 23, when it crosses the equal sign, becomes positive 23. So what I have now is 12x equals 120. And to get rid of the 12, I'm dividing both sides, which makes it x equals 10. Let's look at another example that has fractions this time. 1/5 x plus 6 times of 1/2 x plus 3 equals negative 2. So watch carefully. 1/5 x is one term. 6 times of 1/2 x plus 3 is another term. And minus 2 is another term. So I have three terms in total here. And in this question, the LCD is, if you look at all their denominators, the LCD is 10. So I'm going to multiply everyone by 10. Now, when I take 10 times 1/5, you have to think of what's 10 times 1/5 as in 10 over 1. So that's like 10 over 5, which makes it 2. So the 5 goes into 10 two times, and so this first term becomes 2x. Now, if you look at the second term here, the 6, I do not want to multiply the 10 to the 6 because that's not the one with the denominator. Instead, I'm going to distribute the 10 into the parentheses to get rid of the denominator 2 in this case. So what this next term is going to look like is 6 parentheses 10 times 1/2 is going to be 5x plus 10 times 3 is going to be 30. And that's equal to 10 times negative 2, which makes it negative 20. So when I do that, you notice all the denominators have been cleared. So now I'm back to whole numbers, and back to step 1, I'm supposed to remove parentheses. So right in front of the parentheses, there's a positive 6. I'm going to distribute that in. So what I have is 2x plus 30x plus 6 times 30, which makes it 180, equals negative 20. So I need to combine like terms, which is on the same side. So the 2x and 30x makes it 32x plus 180 equals negative 20. So in order to combine the 180 and the negative 20, they have to be on the same side. So now I'm going to apply addition property, which brings the 180 over as negative 180. So the next line is going to read 32x equals negative 20 minus 180. So 32x is negative 200. Since the two numbers are the same sign, that's when we add them, but we keep the sign. And finally, I'm going to divide both sides by 32. X equals, now watch out for that. You cannot leave your answer as 200 over 32. You need to reduce it. So I'm going to try to divide by 2, which makes it 100 over 16. And I noticed that I can divide some more. So this time I'm going to try dividing by 4, which makes this a 25 and that a 4. And I think I'm done. Watch out for the sign. There's a negative right there. So the final answer is negative 25 over 4. You notice that in the previous examples, we have always been able to get a unique solution for the equations, but that's not always the case. So consider now another example. Solve, say 5 times of 16x minus 1 minus x over 2 equals x over 3 minus 5. So in this question, there's 1, 2, 3, and 4 terms. The LCD in this case is 6. I'm going to multiply every term by 6. So just like the previous example, the 5, I don't need the 6 to help me because it's a whole number. I'm going to distribute the 6 into the parentheses to help to clear the fractions. So this term is going to read 5 times of x minus 6. In the next term, the 2 goes into the 6 3 times, so that's going to read 3x. After the equal sign, the 3 goes into the 6, so that's going to read 2x minus 6 times 5, which makes it 30. Now that the fractions are cleared, I'm going to do step 1, which removes the parentheses. So I'm going to distribute the 5 into the parentheses, which makes it 5x minus 30 minus 3x equals 2x minus 30. So I'm going to combine like terms. That's step 2. 5x minus 3x is 2x minus 30. And on the right side, you notice is again 2x minus 30. Now, even if you don't notice that there's something strange here, and you continue the process, what we're going to do next is to combine like terms by pulling them to the same side. So we have to apply addition property. So I'm going to bring the 2x over, which is going to look like 2x minus 2x. And I'm going to bring the 30 the other side, so which makes it minus 30 plus 30. So the left side reads 0, and the right side reads 0. So this is one of the unique equations, or the special equations, whereby the variables all cancel. So if you recall, in the process of solving, we're trying to look for variables, values that replace the variables to make both sides the same. But in this example, you notice it doesn't matter what we use for the variables, they're going to be the same anyway, because the left side is always 0 and the right side is always 0 at the end. So for this kind of equation, we say that there is infinitely many solutions. Okay, because it doesn't matter what you use for x. You could use x as 0, you could use x as 1, 2, 3, it doesn't matter. Whatever number you use is going to work. So that's why we say it's infinitely many solutions. It's one of the special equations. Okay, so there's yet another one. There's yet another type where it's also going to be something strange happening. Let's see this one. Can you solve 7.3x minus 2 minus 0.9x equals 5x minus 1.8 plus 2 times of 0.7x? Now in this example, let's count. There's 1, 2, 3, 4, 5, 6 terms. So each term I'm going to multiply in this case, because they're all decimals, and to one decimal place, the maximum. Okay, so I'm going to multiply every one by 10. So observe, I'm not just multiplying to the ones with the decimal, I'm multiplying to everyone, every term. Okay, that's the rule. You need to multiply to every single term. So 7.3 times 10 makes it 73x. And 2 times 10 makes it 20. 0.9 times 10 makes it 9x equal 5 times 10 is 50x minus 1.8 times 10, that's 18. Now this is the trick I'm going to apply again. You notice that I don't need to multiply 10 to the 2. Instead, I'm going to multiply 10 to 0.7. So this is going to read 2 times 7x. So in doing so, you notice all the decimals are cleared. Okay, so let's continue. Combine like terms on the same side. 73x minus 9x makes it 64x minus 20 on the left. And 50x minus 18 plus 2 times 7x makes it 14x. I'm going to combine like terms again. which makes this 64x minus 18. So you notice that the both sides are not the same and something strange is going to happen, but let's continue anyways. We're going to bring all the x's to the same side, so 64x, and I'm going to cross this over, so it makes it minus 64x, and minus 18 plus 20. Now, unlike before, you notice that the left side says 0, but the right side does not. Minus 18 plus 20 is going to be equal to 2. So this is another strange happening here, because you notice again the variables have disappeared, but what's left is two numbers that don't match. Numbers don't match. So when they don't match like that, it doesn't matter what you use for the variable, they're never going to be true. So the answer to this type of problem is called no solution. So to summarize, there are altogether three types of equations. The first type is called conditional, which is the ones that we're familiar with. It always ends up with only one solution. The two other types, the special ones, the next one is called the identity, which actually ends up with infinitely many solutions. Okay, so that's the type where all the variables cancel and the two numbers match. So one side says 0, the other side says 0. Or one side says 5, the other side says 5. They're identical, and so we call the type identity, and those have infinitely many solutions. Okay, so since they're always going to be same, it doesn't matter what you use for the variable. The last one, which is the very last example I just showed you, that's called the contradiction. And this one is the one with no solution. So there you go. Those are the three types.